am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science, Jesus and Mary College, University of Delhi. So friends, in the last lecture, we were talking about the various techniques which are used for data pre-processing in data mining. And we had looked at the different, the different ways in which these techniques are used, and we were talking about aggregation of data sets, of aggregation of attributes, aggregation of data objects in order to, reduce the number of data objects which are present for data mining. So we are trying to build, we are trying to coalesce, we are trying to bring out multiple transactions, we are trying to bring them into one transaction, we are trying to sort of group them into one transaction. So we were looking at this example in the last lecture, and we were talking about the different transactions. This example, this data set basically talks about the different transactions which took place in different stores of a particular supermarket chain, okay, and for each customer purchase we have a single transaction. So if we would like to aggregate this data, so we can do this on multiple attributes. So one is that we try to aggregate the data on store location. So all the transactions that took place in a particular store, we bring them together so that we will have as many number of transactions as there are number of stores. So for every store we will have only one transaction. So we will add up all the transactions in this case. Then we understand another thing, that quantitative attributes, like for example price, these are easy to be aggregated because you can calculate the total price or you can calculate the average price. Qualitative attributes, like for example item. Now item cannot be aggregated as such, but what we can do is that we can combine similar items and make them into one head. Like for example, all electronic related purchases like watch or television, etc., these can be clubbed and they can be put into a higher level category, right. So this is another way in which the data can be aggregated. So we can aggregate it based on items, we can aggregate it based on store location, right. So the data, it can also be viewed in the form of a multi-dimensional array, and where each attribute is a dimension, right. We have already discussed this aspect. Now for the viewpoint of aggregation is basically the process of eliminating attribute, such as the type of item, or we are reducing the number of values of a particular attribute. So this type of aggregation is very commonly used in the OLAP system, like online analytical processing system, where we will use limited number of attributes. So instead of having bigger attributes, we will look at dimensionality reduction aspect. Now what are the motivations? Why why should one go in for this kind of aggregation or making the data set smaller? Now the very important aspect is that if you are using a smaller data set, if you are having a data reduction and finally you get a smaller data set, so the smaller data set would require less memory, it will require lesser processing time, and therefore we can even run very expensive data mining algorithm on data sets which are of limited size, which have got limited number of attributes or limited number of dimensions, right. Then secondly, aggregation also changes the scope or the scale by providing a high level view of the data instead of a low level view. So instead of looking at individual items, we are now looking at the individual stores, right. Instead of looking at the daily sales of each item, we are looking at the monthly sales of a particular item in the entire region. And also another important aspect, which is a very major motivation for using aggregation, is that the behavior of groups of objects or attributes is more stable than that of individual objects or attributes. That is, if you look at the price, right. So the price of individual item is going to change more often. The total price will show a less amount of change, a less amount of variation. So therefore, when you look at aggregate behaviors or the behaviors of aggregates of objects, they are more stable and therefore they lead to more analysis, the more efficient analysis. And also because we understand that it is a statistical fact that aggregate quantities like average or total, they have less variability than individual values which are being aggregated, right. So a disadvantage of aggregation, what we can see, is a potential loss of interesting detail. That is because now you are only looking at monthly sales, so you cannot get information about the which day of the week a particular item is sold the maximum. So this kind of detail of course you will miss, but the overall reduction in the number of attributes is going to make running of expensive algorithms easier, and it is also going to create data sets which will be more stable, which will have less amount of variability among them. The second technique which is used in pre-processing is sampling, right. Sampling, we all understand, sampling is a very commonly used approach in statistics and in other domains of knowledge also. So in sampling, basically what we are doing, that instead of looking at the complete population, we will be selecting a subset of the data objects which we will be analyzing, right. So it has been used for preliminary investigation of data and also in the final data analysis. Now sampling is a very crucial technique which is used, and it is most commonly used technique also, and it is very useful in data mining also, right. However, the motivations for what data mining uses sampling and for what statistics uses sampling are different, because statisticians, they will use sampling to obtain entire set of data of interest, right, and it will be too expensive and too time consuming, while data miners, they will usually sample because it is too computationally expensive in terms of memory and time required to process all the data, because we are looking at huge data sets. So we cannot look at the complete population, we need to look at a subset, so that we can optimize the time, processing time and the memory requirements, right. So in some cases, the sampling algorithm, it will reduce the data size to a point where a better but more computationally expensive algorithm can be used, because you have reduced the size of your data set. So therefore definitely you can run very computationally expensive algorithm which will give you better results, right. So what is the key principle that is used for effective sampling? That you are using a sample which will work almost as well as using the entire data set if the sample is representative. That is, we are saying that a representative sample will show the properties, will show all the properties exactly the way the entire population is going to show, as the original set of data is going to show. The properties will be simple, right. So sampling is a statistical process, and the representativeness of a particular sample will vary, and we have to choose a particular scheme which guarantees a high probability of getting a representative sample. So there are multiple approaches or multiple schemes which are used for sampling, right. So let us look at some of the sampling approaches. So the first and foremost is the random sampling, then we look at stratified sampling, and we look at progressive sampling. So first and the most simplest of the sampling techniques is the random sampling technique. So in random sampling, basically the probability of an object getting selected in the sample is the same, right. So in this case what happens is that if you have a population, then the sampling object, the samples are picked on random basis. So each object will have equal probability of getting selected as a sample. Random sampling is very commonly used in statistical experiments, in mathematical experiments. Now random sampling basically is used when all the data objects which are being used are similar, they have similar attribute. Random sampling, it is of, further it can be of two types, one is with replacement and the other is without replacement. So when we say that we are using the sampling with replacement, it means that once an object is selected in the sample, then the object is not going to remain in the data set, in the population, right. And without replacement means that once the object is selected in the particular sample range, then it will be removed, right. So basically in this case what happens is, now with replacement and without replacement is not just related to random sampling, it can work for other types of sampling only. That is, once you pick up an object, whether that object still remains in the population or it is removed from the population. So if the object is removed from the population, then it is more fair, because then we say that the chances of selection of a particular object are equal, because every object will only have one instance of getting selected into the sample range, right. Now in this case we have another type. Now when we have all objects are similar, then we use random sampling. But in case we have got a scenario where we have objects are of different types, that is, they are not all the same, the attributes of the objects may be different. So you have a large number of objects which are which are lying on the boundary. So therefore then in that case your sample will not be a representative sample if you just pick up the samples randomly. In this case what we do is that we go for stratified sampling. Stratified sampling means that we are going to create groups, or we are going to create clusters of objects of each type, and from each cluster we will pick up the samples, right. So in this case what will happen, that even though the objects are different, all different types of objects will be equally represented in our final sample, so that the population is completely represented in the sample, because as we already said that the ideal sample would be which shows the properties of the complete population. So if different types of objects are there, then we need to use a technique of stratified sampling or group based sampling, right. Then we have the progressive sampling technique. Progressive sampling technique is another type of technique, but before we actually look at progressive sampling, we also need to understand that how sampling, if it is not done appropriately, can lead to loss of information, right. So for example, if we look at this figure, in this we have a data set which has got 8,000 points. So this is the complete population. Now from this, if we pick up a sample of 2000 points and we pick up another sample of 500 points, so we can see that the sample which is having 2000 points is still representative of the population, because the pattern which is shown in the population is also shown in the sample of 2000 points. But if we look at a sample of 500 points, this pattern is completely lost. So therefore we say that this sample size of 500 points is not a representative sample size of the population. Hence it is also very important that we choose the correct sample size, because otherwise sampling can also lead to loss of information, loss of important detail which is present in the data. Now progressive sampling basically is another different approach, because we are looking at how information can be lost while choosing a wrong type of sample size, right. So therefore the next approach which we look at is progressive sample, where we are looking at a sample size of a sample of sufficient size so that the information loss does not take place. So in this case what we are doing is we are eliminating the need to determine the correct sample size initially, right. So, it requires that there be a way to evaluate the sample to judge if it is large enough. So, we are going to gradually increase the sample size each time, so that we attain a point where our model, the predictive model, works in the most efficient format. So, the accuracy of the predictive model will increase as your sample size will increase. This will happen up to a particular point, right. That point is known as the leveling off point, right. So, after that point the accuracy will become stagnant. So, when the accuracy reaches the leveling off point, that is the appropriate sample size. So, gradual increase in the sample size till the time the prediction model will work in the most efficient point is the whole idea of progressive sampling. So, what we are doing, we are keeping a track of the change in accuracy of the model as we are using larger and larger samples, right. So, we take the other samples which are close to the current the size of the current sample, we get an estimate of how close we are getting to the leveling off point, and therefore, when you get close to the leveling off point, then you will stop the sampling, right. Now, the entire exercise of aggregation was focusing on the idea that we are trying to reduce the number of the number of attributes or the number of features, or sometimes we also call them as dimensions. So, we come across data sets that have got large number of features, like for example, if we have a data set of documents, right, where each document is represented by a vector whose components are the frequency with which each word occurs in the document, right. So, we can understand that how many number of attributes are going to be there in the data set, because we need to keep a count of all the words which are occurring in the document, right. So, it can have tens of hundreds of even thousands of attributes which can be there. Another example could be that we are looking at a set of time series data, right. So, we are looking at the closing price of various stocks for over a period of say 30 years. Now, in this case also the attributes which are the prices of specific days, they will also be in thousands. So, such kind of enormous data sets which have got thousands of attributes, they need to undergo a task of dimensionality reduction. That is, we will try to reduce the number of attributes which are present in these large data sets, right. So, we can use different techniques for dimensionality reduction. Okay. So, we can use it by creating combining the old attributes, or we can create a new attribute, we can create a subset of the attribute. So, dimensionality reduction by different techniques it can be done. It can also be done through feature selection. So, there are multiple techniques for by using which the number of attributes in a data set can be reduced. Now, it is very clear that there are multiple benefits which accrue when you are undergoing this exercise of dimensionality reduction. The first and foremost is that many data mining algorithms, they will work better if the dimensionality or the number of attributes is lower, right. The algorithms are designed for a specific number of attributes, and they will work most optimally if they are working with a lower range of attributes than what is specified. Then it can also lead to a more understandable model, because models they generally have fewer attributes. So, the model which we are creating, it will align easily to that, right. More so, it is also easy to visualize the data in the 2D and 3D framework when the dimensionality is reduced, it is in control. And also the most obvious is that you will reduce the time and the memory requirements of the data mining algorithm if you are using a less number of attribute, if you are using a reduction in dimensionality. When we talk about dimensionality or the number of attributes in the data set, a very commonly used phrase which comes along is known as the curse of dimensionality. The curse of dimensionality, basically it refers to the phenomena that many types of data analysis, they become very hard, they become significantly hard as the dimensionality of the data increases, right. So, the data becomes increasingly sparse, and the space in which the data is lying, that also the data is not going to reveal very significant patterns, because we will see that the sample which you are taking is not representative sample of all possible objects, because there are so many attributes in your data that to establish correlation between the two attributes or pairs of attributes will also be very difficult, right. So, there will not be enough data objects which will allow you to create a model which you can assign a class to all possible objects. So, clustering also, because the clustering, the difference in the density and in the distance between the points which are critical for clustering also becomes very less meaningful. So, therefore, this high dimensional data will lead to reduced classification accuracy and poor quality clusters. So, the whole idea is to keep the data set in a way so that it has got the minimum number of features or the minimum number of attributes or the minimum number of dimensions, so that the analysis becomes most optimum. Now, in order to undertake dimensionality reduction or to reduce the number of dimensions, it is commonly said that only a subset of the features may be used. Now, please note that the word feature, attribute or dimension is used as synonym here, right. So, subset means that you are not going to use all the features, but it will one will has to select which features will be used, right. So, it so we will look at two aspects of the features. One is the aspect of redundancy and the other is the aspect of relevancy. So, we will only take those features which are non-redundant and relevant for the particular application or for the particular algorithm, so that the information is not lost in this case. So, redundant features which will duplicate much or all of the information contained in one or more of the attributes. So, we will try to reduce those. Say for example, if in a data set we are keeping the sales tax value for each item and the purchase price of each item. Now, these two attributes, they are actually conveying similar information, they are actually redundant features. So, one of these can be easily selected, there is no problem in this, right. Another could be irrelevant features which are providing information which will not be utilized. Say for example, if you have a data set in which you have student IDs and grades. Now, student IDs are in no way relevant to their grades. So, in this case student ID will be an irrelevant feature and therefore, it could be removed, so that the accuracy of the classification algorithm or the quality of the cluster can be retained. Now, how does one select the best subset of the features? Which is frequently requires a systematic approach for this. You cannot just randomly remove certain attributes and select certain attributes and leave the others. It requires a scientific approach, and the ideal approach for feature selection is to try all possible subsets of features as input to the data mining algorithm of interest, and then take the subset that produces the best result, right. So, what we will do, we will progressively run the data mining algorithm with all the possible subsets of attributes which are there in the data set, right. So, now this is a very advantageous method because it will reflect the objectives and bias of the data mining algorithm that will eventually be used. But the problem is that if you have say n attributes, right. So, then you will create 2 raised to the power n subsets of attributes using this. So therefore, it will create so many subsets that the entire approach will become impractical. It cannot be done in most situations. So therefore, alternate strategies have to be used for this purpose, right. So this particular strategy of feature selection using subsets will not work. So there are three approaches instead of this approach which are used. First is embedded, second is filter, and the third is wrapper approach. Now in embedded approach, basically the algorithm itself will pick up certain fields on its own. The algorithm has been designed in a way that it can undertake feature selection. Okay. So therefore, the algorithm will decide and which is to be picked up, which one to be ignored. Now this cannot be used in most scenarios because the classification algorithms are differently designed. The most popular way of feature selection is using filter approach, in which the data before the algorithm is run, actually the data is there is another method which is used for the selection of the particular attributes from the data. And in wrapper approach, the method which is used for the target data mining algorithm is actually a black box. So to find the best subset of the attributes in a way which is similar to that ideal algorithm described below. So basically it will be without enumerating all possible subsets. So friends, we have discussed about the various ways in which feature reduction can be done, dimensionality reduction can be done in this lecture. We will be continuing with this discussion in the following lecture. Please keep watching CEC till then. Thank you.